Okay, sir, start.
Okay, sir. Welcome to this session. Actually, today is continue the electrochemistry, but today's session I'm explain about the surface chemistry. Okay, it is a fourth chapter of the second year chemistry. Here, the chapter is containing 4 marks according to your previous question papers. Okay, here, what is the meaning of surface? You know already, surface is nothing but as what? Upper layer, upper part, where the chemical reactions are taking place at the upper layer of the bulk of solids and liquids. Those entire chemical process are read down under the surface chemistry. Okay, so then in the surface chemistry, we have to know about the following contents like adsorption, catalysis, colloids, emulsions, applications of colloids. Apart from this, first we have to learn about the adsorption. Okay, students, adsorption. It is a important terminology in this chapter. That's why you have to more concentrate on the adsorption. Okay, right. Before that, to entering the adsorption, we have to know about the important term that is interface. What is that? Interface. Here, the interface is normally few molecules thick, but its area depends on the size of the particles of bulk. That means what? Here, if any two substances are contact to each other, that contact region, that contact part is called interface. That contact part is called what? Interface. The interface word is came from the interaction. Interaction. Okay. Here the interface is represented by hyphen symbol or slash symbol. Okay, students, the interface is represented by hyphen symbol or slash symbol. Okay, for example, here solid is interface with the gas. That's why here clearly mentioned here hyphen. Hyphen is indicating as the interface. That means what? Solid is interact with the gas. Or similarly here solid slash gas. Here slash also indicating as the interface in between solid as well as gas. Okay. Here I have to provide one example clearly here. Here this region. Okay. Here this region is called gas region. This region is called solid region. This region is called liquid region. But here the gas is interact with the solid. The gas is interact with the solid. That's why this is called gas solid interface. What I mentioned here? Gas solid interface. Similarly, here the liquid. Here the liquid is interact with the gas. The liquid is interact with the gas. Therefore, it is called as gas liquid interface. What is this? Gas liquid interface. Okay. So then here similarly another one. Here it is solid. Solid is interact with the liquid. Solid is interact with the liquid. Therefore, this is called solid liquid interface. Okay. During this diagram, we have to conclude the interface is nothing but what? Contacting part. contacting, but any two substances or any two molecules are contact with each other, that contact part is called interface. It is an important term. Based on this, we have to know the following terminology like absorption as well as adsorption. Okay, absorption as well as adsorption. Okay, then here it is important term. What is the meaning of absorption? Here, the uniform distribution of a substance throughout the bulk of the solid substance is known as absorption. Absorption. That means what? Already I told you here. AB means what? Here it is indicating as the absorption. AB is equal, simply we have to know about the AB is equal to distribute the entire bulk. To distribute the entire bulk, but not upper part, but not entire part, but it is distribute the entire part of the bulk, like solid, or liquid. That is called absorption. AB means what? Absorption. For example, I have to provide one example here. Chalk stick dipped in ink. It is a internal part of our life. In childhood days, we have to observe this process. Okay, chalk stick dipped in ink. That means what? When take the chalk piece and which is dipped in the ink is occupied the entire part of the chalk sticks. That means what? Ink is concentrated the entire part of the chalk sticks, entire part of the chalk sticks. So this is about the best example for absorption. What is that? Absorption. Okay. Then we are enter into adsorption. That means adsorption. Here in adsorption, the accumulation or concentration of a substance on the surface rather than in the bulk of solid or liquid is known as adsorption. Simply, we have to conclude within one line. What is that? Adsorption means to distribute only on the surface of the bulk. That means what? To distribute only on the surface of the bulk. Okay, here adsorption is a surface phenomenon. Here absorption is a entire phenomenon. It's clear, guys? Absorption is a entire phenomenon, entire bulk, to distribute the entire bulk. But similarly, absorption is only surface of the bulk. Okay, only surface of the bulk. But most of the students are confused here. Simple. What is absorption? What is adsorption? Always AB is indicating as the absorption. Okay, AB is indicating as the absorption. Here AB is indicating as the absorption. AD is indicating as the adsorption. Here slide change. AB, here it is AD. Don't confuse it. Okay, but what is the example under adsorption? What is the example under adsorption? Here in adsorption, example is adsorption of gases like oxygen, hydrogen, chlorine, etc. gases are present on the charcoal. For example, in coal mine areas, the gases like oxygen, hydrogen, chlorine gases are concentrate on the surface of the charcoal, but not internal part of the charcoal. That means what? Here the gases are occupied only surface area of the charcoal. Once I repeat you, the gases are occupied or concentrate on the surface area of the charcoal. Okay, students, surface area of the charcoal. This is about the absorption. Okay, this is about the absorption as well as adsorption. Don't confuse. Okay, so then we are enter into here. I have to mention here this enter here absorption. In absorption, the molecules are occupied internal body of the bulk. Yeah, it is internal body of the bulk. Whereas here, adsorption, I clearly mentioned here, the black color. Here, adsorption, here to occupy only surface area of the bulk. Only surface area of the bulk, but not internal part of the bulk. That's why it is called as adsorption. It is called as AB, absorption. AB means what? Absorption. AD means what? Adsorption. AD means always to occupy surface area. AB means always to occupy internal part of the bulk. Okay. So this is about the absorption as well as adsorption. Okay, clear, my dear students? Okay, then here mechanism of adsorption. Very, very important one, right? The adsorption is a surface phenomenon. Actually, adsorption is a surface phenomenon. AD means what? Surface area of the bulk of solid or liquid. That is called adsorption. Here, adsorption is surface phenomenon, and then second point is it arises because of unbalanced forces on the surface of the solid and liquid. In generally, there is available unbalanced forces on the surface of the solid or liquids. Okay, so here the surface is under tension due to the unbalanced forces. Here the surface is present under tension due to the unbalanced forces. To balancing the surface area, that part will attract the other molecules or another substances, or to retain their function of the surface area. The process, due to this reason, here adsorption is taking place. To retaining of the molecules, this process is under mechanism of the adsorption. Simply, we have to conclude one point: to satisfy or to balance, there will taking the adsorption process. This entire process is called mechanism of the adsorption. I already mentioned here, yeah, this diagram is indicating as the adsorption of the mechanism. Okay, so this is about the adsorption process. Okay, then let's here the factors affecting on the adsorption. It is also important one during your IPE purpose. We will more concentrate on this question. Okay, factors affecting on the adsorption. Here the first column is indicating as the factors affecting adsorption, and second column is indicating as effect on adsorption. Here the left column, that is first point, solute. Okay, solute concentration. Here solute concentration, here increased solute concentration will be increase the amount of adsorption occurring at equilibrium until a limiting value is reached? Very simple. By increasing solute concentration, increases the adsorption process. Once again, repeat you, my dear students. Increasing solute concentration increases the adsorption process. Increases the adsorption process. Okay. So this is about the solute concentration. Then what about the temperature? Here, actually, temperature. Before that, we have to know one thing. Actually, the adsorption process is a exothermic process. Exothermic process. That means it is involving in exothermic. What is the meaning of exothermic? Exothermic means what? To releases the temperature. Here I have to mention here exothermic. To releases the temperature. Therefore, an increase in temperature will be decreases the adsorption. That means what? By increasing temperature, adsorption process is always decreases. Okay, increasing temperature to decreases the adsorption process. Adsorption process. Okay, so that means what? Temperature is indirect proportional to the adsorption process. Right. Then the third point is pH. Here pH influences the rate of the ionization of solute. Rate of the ionization of the solute. Hence, the effect is depend on the species that is more strongly adsorbed. That means what? Simply we have to conclude here the pH effect is depends upon the number of species, that is nature of the species. Nature of the species. Okay, so this is about the pH. Then last one, that is surface area of adsorbent. Okay, we discussed later about the adsorbent, but we have to learn about this small part. Okay, surface area of the adsorbent, I mean absorbent. Here, an increase in surface area will be increases the extent of adsorption. That means what? If increase the surface area of the absorbent to increases the adsorption process. To increases the adsorption process. By simple only by increasing adsorbent to increases the adsorption process. Adsorption process. Okay, clear, my dear students? Then we are enter into another part, that is sorption. Here, what is the meaning of sorption? Here, in case of some substances, both adsorption and absorption takes place. This is phenomenon is called sorption. I already mentioned here. Sorption is equal to alternating running of absorption as well as adsorption. Some spelling mistake is there. Absorption as well as adsorption is called sorption. Okay, this is about the sorption. Sorption means what? It is containing always absorption as well as adsorption. For example, I have to provide one example here. Dyeing of cotton by azo dyes. Dyeing of cotton by azo dyes. Here, what is the meaning of dyeing? Dyeing means what? Just coloring the cotton by using azo dyes. In this process, there is available two terminologies, two steps. Number one is absorption step. Number two is adsorption steps. This is the best example for sorption. Okay, this is the best example for sorption. Similarly, what is the meaning of desorption? You know already, D means what? Removing or eliminating. That means what? Eliminating the sorption. Eliminating the sorption process is called desorption. Here definition is the process of removing removing an adsorbed substance from a surface on the which it is adsorbed is called desorption. That means what? For example, I have to provide here one example. When water is exposed to that exposed to heat, then oxygen dissolves from water. For example, water is exposed to heat. What happen here in general? It is also in our internal part of in our life. Okay, so generally we have to see this example daily life, right? Here, when water is heated, from that water, here oxygen is dissolves. Oxygen is dissolves. That process is called desorption. That process is called desorption. Okay, here sorption and desorption. Sorption means what? Once again, repeat you. Absorption plus adsorption is called sorption. Simply, what about the desorption? To removing or to eliminating the adsorption process is called desorptions. Best example for sorption is dyeing of cotton by azodize. Best example for desorption is when water is exposed to heat, then oxygen dissolves from water. Okay, so this is about the best example under sorption as well as desorptions. Okay, students, are you follow me? I hope you will understand my concept. Then adsorbent. It is also important term. Adsorbent. What is the meaning of adsorbent? Here, the substance on whose surface the adsorption occurs is known as adsorbent. That means what? Whose surface the adsorption is occur, that is called as adsorbent. Simply, hello? Simply, it is nothing but a what? Simply, it is nothing but a receiver. Adsorbent is nothing but a what? Receiver. Okay. Here, what about the adsorbate? Here, slight change. Here, ENT means what? Adsorbent. I mean, BENT means what? Adsorbent. Here, BAT means what? Adsorbate. Here, BENT, that is adsorbent, is nothing but about simple. It is receiver or observer. Okay, receiver or observer. What about the adsorbate? Adsorbate is nothing but about how to provide your definition. The substance, those molecules get adsorbed on the surface of the adsorbent is known as adsorbate. That means what? The substance, those molecules get adsorbed on the surface of the adsorbent is known as adsorbate. Okay, for example, by using this example, we have to know about the differences in between adsorbent as well as adsorbate. In adsorption of acetic acid by charcoal. Here, once again repeat you, in the adsorption of acetic acid by charcoal. What happened here? Here, acetic acid is adsorbate and the charcoal is adsorbent. What you understood by this one? Just acetic acid is, okay, acetic acid is occupied on the charcoal pot, That's why acetic acid is acting as a adsorbate and charcoal is acting as a adsorbent. Once again repeat you, don't confuse my dear students. Try to understand me. Here important term. Once again repeat you. Here, sorry for the inconvenience. Yeah, here, acetic acid by charcoal. Acetic acid is occupied on the charcoal. That's why acetic acid is acting as a adsorbate and charcoal is acting as a adsorbent. Okay, so then here clear I mentioned here adsorbate. Here it is. That means what? Here this circles are nothing but as what? It is called as adsorbates. Adsorbates. That means what? It is occupy the bulk of solid or bulk of liquid. That's why this red color small circles are indicating as the adsorbate. Adsorbate look like acetic acid. Just I told you acetic acid. Here the red circles are, that is small red circles are acting as a here acetic acid. What about this one here? This bulk, this solid or liquid is acting as a adsorbent. Adsorbent look like charcoal. Okay, just I told you here it is look like charcoal, here it is look like acetic acid. Here acetic acid is occupied on the what? Charcoal region. This is a charcoal, this is a acetic acid. That's why this is best example for adsorbate and this is best example for adsorbent. Adsorbent, don't confuse. But most of students are confused here also. What is adsorbate and what is adsorbent? Okay, so this is actually I told you just now always adsorption process. Adsorption process also containing adsorbate as well as adsorbent. Okay, adsorbate as well as adsorbent. So this is called as adsorption, right? Then the differences, it is very, very important one. The differences between adsorption and absorption. Okay, here this column is indicating as the absorption. This column is indicating as the adsorption. Okay, so the first column, it is absorption, it is adsorption. But first we have to learn about the absorption. It is the phenomenon in which particles of gas or liquid get uniformly distributed throughout the bulk of the solid. I told you at the beginning of this chapter, it is a absorption is indicating as a uniform distribution. Simple, uniform distribution of entire bulk of solids or liquids are called absorption. Okay, then what about this one? Adsorption. It is the phenomenon of higher concentration of particles of gas or liquid on the surface than in the bulk. That means what? This is a phenomenon. It will more concentrate on the surface area. On the surface area, but not inner part or internal part of the bulk. That is called adsorption. Adsorption. Here it is absorption. Here it is adsorption. Don't confuse, my dear students. Okay. Then here second point occurs at uniform rate. It is occurs at a uniform rate. Here the adsorption is occurs at a rapid in the beginning. Actually, adsorption process is more rapid at the beginning and rate slowly decreases. That means what? Adsorption process at the beginning it is very fast and after that it is very slow down. Go on going, I mean it is very slow down. Okay, so this is about the adsorption of the second point. And then third point of the absorption. Here best example for absorption is anhydrous calcium chloride absorb the water. It is the best example for absorption. Generally, anhydrous. What is the meaning of anhydrous? Without water. Without water is called anhydrous. Okay. Anhydrous calcium chloride absorb the water. Absorb the water. But what about the example under adsorption? Here, silica gel. Silica gel adsorb the water vapor. Silica gel always adsorb the water vapor. This is a best example under adsorption as well as absorption. Once again repeat you, calcium chloride is a best example under absorption. Silica gel is a best example under adsorption. Adsorption. Don't confuse. It is a little bit important differences in between adsorption as well as absorption. Okay, clear students? Then the types of adsorption. In this chapter, we have to learn about the more part during the adsorption. Here, based on their physical properties, the adsorption process is divided into two types. Adsorption process is divided into two types. Number one is physisorption. Number two is chemisorption. Physisorption and chemisorption. Right? Phi plus sorption, physisorption. Chem plus sorption, that is chemisorption. Right? It is very, very important one. Okay, that's why you have to more concentrate on this question. It is the maximum question paper is containing this question. So that's why you have to more focus on it. Okay, during your IP purpose. Right? Then, yes, it is very, very important one. This column is indicating as the physisorption. Okay, this column is indicating as the chemisorption. Right? Here, the first point under physisorption. Okay, very, very important one. Let us concentrate on it. Right? The first point under physisorption is the process is weak due to van der Waals forces. Actually, physisorption is a weak, it will containing weak process. It will show the weakness because of due to the weak van der Waals forces. Whereas here, that is chemisorption, the first point is the process is strong due to the chemical forces. Due to the chemical forces. In generally, the chemical reactions are also very strong when compared with the physical properties like water maybe reactions also. Similarly, second point under physisorption. The process is reversible, but this process is irreversible. Here, what is the meaning of reversible? Here, there is available forward reaction as well as backward reaction. That's why the process is called reversible reaction. Forward reaction as well as backward reaction. Both reactions are occurred in physisorption. Okay. Then second point, this process is irreversible. That means what? Always it will show the forward reaction. Forward reaction. That's why this is called, it will show the irreversible nature. It will show the irreversible nature. Similarly, the third point. This is a quick process. That is, takes place quickly. That means what? Always physisorption will show the quick process. Within the fraction of second, within the fraction of minutes, it will be completed. Whereas here in chemisorption, that is third point is, this is slow process. In generally, all chemical reactions are involving in the slow reactions. That's why to make fastness in chemical reactions, we have to add the catalyst. That means what? By addition of catalyst, it will move the fastness. It will move the very within fraction of minutes. It will complete it by addition of the catalyst. That means what? The chemisorption is containing slow Okay, slow process. Similarly, fourth point, the process decreases with increase of the temperature. It is, that means that the physisorption when increase, when increase the temperature, what happen here? The process decreases with increasing temperature. If increase the temperature, the physisorption is decreases. If increase the temperature, the physisorption is decreases. But it is quite opposite. The process increasing with what is that? The process increases with the increase of the temperature. That means what? By increasing temperature, increases the chemisorption. Increases the chemisorption. But here, by increasing temperature, decreases the physisorption. This is about the fourth point under physisorption as well as chemisorption. Then fifth point, that is, this is multi-layered process. Multi means what? There is available, there is form more than one layers in the physisorption. Whereas here under chemisorption, this is a unilayered process. That means what? It will show the only one layer under chemisorption. By visiting this unilayer, we have to conclude, yes, it is a chemisorption. By visiting the multi-layer, by observing the multi-layer, yes, it is under physisorption process. Okay. Then the last point, that is sixth point, the process depends mainly on the nature of the adsorbent. Mainly on the nature of the adsorbent. So here under chemisorption, the sixth point is the process depends both on the nature of the adsorbent as well as adsorbate. Once I repeat you, it is important point. In physisorption, this process is depends upon only adsorbent, whereas in chemisorption, it will depends upon adsorbent as well as adsorbate. Adsorbent as well as adsorbate. That means what? In chemisorption here, adsorbent and adsorbate both are play the important role. Both are play the important role in the chemisorption. Whereas in physisorption, only adsorbent will play the important role to run the physisorption reaction. Okay, this is about the important points, that is differences in between physisorption as well as chemisorption. Okay, my dear students, are you follow me? Try to understand me. Right, then here, right, here isotherm. What is the meaning of iso? Iso means what? Same or equal. Same or equal. Therm means what? Like, temperature. That means what? There is no changes in temperature. That means what? Always by putting temperature constant. By putting temperature constant. Okay, here actually this is also right. Here the isotherms. Under this, we have to know about the Freundlich adsorption isotherm. Okay, there is available another one, Longview isotherm also there, but according to our syllabus, it is important one. That is what? Freundlich adsorption isotherm. Here the flat versus log. The flat versus log. Yeah, this is log x by m as well as log p. That flat is called isotherm. Here, but when we will draw the log x by m as well as log p, we have to observe the slope. Yeah, this is a slope. The slope is indicating as the 1 by n, as well as this region. This region is called intercept, which is represented by the log k. Here, this diagram. This process is proposed by the Freundlich scientist. Therefore, it is called as Freundlich adsorption isotherm. But here, according to Freundlich adsorption isotherm, we have to conclude the one simple equation, that is x by m is equal to k comma p power 1 by n. This principle is nothing but what? Freundlich adsorption isotherm. Here, x by m is equal to extent of adsorption. Here, x by m is equal to extent of adsorption. Okay, here x by m is equal to extent of adsorption. Similarly, here p. Yeah, this is the p. P is equal to pressure. P is equal to pressure. But what about the K? Here, already I told you K and N are constant, which depends on the nature of the adsorbent and the gas of the particular temperature. That means what? X by m is equal to k comma p power 1 by n principle is a nothing but as what? Freundlich adsorption isotherm principle. Okay, so this is about the Freundlich. Right here, what happened here? Always we have to keep the temperature constant. That means what? There is no changes in the temperature. There is no changes in the temperature. That plot is called Freundlich adsorption isotherm. This is a equation. X by m is equal to k comma p power 1 by n is a equation for the Freundlich adsorption isotherm. Okay, so it is asked for sometimes 2 marks also, right? So then here, yeah, applications of adsorption. Applications of adsorption. Here it is also very important one. Under this, the first point is gas mask. Gas mask, a device which consists of activated charcoal or mixture of adsorbent in usually used by coal mines to adsorb the poisonous gases during breathing. That means what? Very simple. Here, gas mask. In general, we have to see where the coal mines areas, the workers are wear the gas mask. Why? Because why they are wear the gas mask? To avoid the poisonous gases. To avoid the poisonous gases, the coal mines area workers are wear the gas mask. Because of that mask is adsorb the poisonous gases like carbon monoxide and sulfur dioxide gases. So that's why on that process there is available adsorption process. There is view the adsorption process. Okay, it is very important one. Okay, this is about the gas mask. Okay, right then here second point is control of humidity. Here, silica gel and alumina gel are used as adsorbents for removing or mixture and controlling the humidity of air in rooms. For example, by using silica gel and alumina gel, it will adsorb the or to remove the humidity of air rooms. Humidity of air. In generally, the air is containing some humidity is containing different humidity in our air. Then we have to use the silica gel. It will remove that humidity from our atmosphere. That is the best example under applications of the adsorption. Okay, then removal of coloring matter from solution. Here, animal charcoal is removes the colors of impure colored solution by adsorbing the impurities responsible for the color. That means what? By using animal charcoal, it will remove the colors of impure colors. On some process there is available impure colors. On that process, to removing impure colors, we have to use the adsorption process. We have to use the adsorption process. What about here? That is separation of inert gases. For example, in the mixture there is available so many gases. On that process, we have to separate the inert gases. Then we have to use the adsorption process. We have to use the adsorption process. Okay, so this is about the applications of the adsorption. What are those applications? Number one is gas mask. Number two is control of humidity. Number three is removal of coloring matter from solution. And number four is separation of inert gases. These four are important uses under the adsorption process. There is available so many uses, but apart from that, we have to highlight the only important uses under the adsorption. Okay, so this is about the adsorption uses or applications of the adsorption. Right here in this session, we have to discuss about the what is that interface. Okay, interface as well as adsorption, absorption, and their differences. Okay, and their differences with examples, and also sorption, desorptions, and also sorption and desorption. The differences in between the physisorption as well as chemisorption. Okay, physisorption as well as chemisorption, and also the factors affecting on the adsorption. The factors affecting on the adsorption. Okay, and also last one, that is applications of the adsorption. Okay, in this session, these all points are explained for you. Okay, explained for you. That's why this is about the important terminology under the surface chemistry chapter. Okay, thank you. Okay, I will